Hello everyone. Today I'm going to be going over a bunch of practice questions for linear functions. So I would recommend you try these out on your own before you watch this video. I will also do my best to put links to each of the questions in the description. We'll see if I can figure that out. So yeah, let's get started. Alright, so question number 1, graph each of the following. Put the lines for A to E on the first grid and F to J on the second, so that's at the bottom of the page. Label each line with its corresponding letter. Great. Okay, so this first one, graph the line 2y equals 3x minus 1 by completing the table of values and plotting the points. So probably the old-fashioned way to do this is start with this equation, plug the values of x into this and solve for y. So we would do 2y equals 3 times x, so let's try for 3, minus 1, so 3 times 3 is 9, 9 minus 1 is 8, so we have 2y equals 8, and divide both sides by 2, we get y equals 4. Okay, and you can continue that procedure for the other two values. You get 1 and negative a half there. And similar, I'll just make some space here, for the x value here. This time we're given y, so we do 2 times negative 5 equals 3x minus 1, and we just solve for the corresponding value of x. So that would be negative 10 equals 3x minus 1, so that would work out to negative 9 equals 3x. So divide both sides by 3, we get x equals negative 3. So negative 3 goes there. Obviously you can use your graphing calculator for this question as well. So if I were to do that with my graphing calculator, I would probably write this in, well, you got to have it as y equals something. So in order to do that, you got to divide both sides by 2. So you'd have 3 halves x minus 1 half. And you could put that into your graphing calculator and bring up the table of values and just get those right off of your calculator. Okay, so now we can graph it. So I guess we'll have to plot a few points here. So 3, 4 goes there, 1, 1 goes there, 0 minus a half goes there roughly, and minus 3, minus 5 is there. So connect the dots. We've got a line. We'll try to. Okay, and that's about right. So that would be A in both directions. On to B, the graph of y equals 4. So y equals 4 for all values of x. So just jump straight to the line, y equals 4. Pretty straightforward, that one, hopefully. So that's B. Next, graph the line y equals x minus 5. So it's convenient, it's in slope y-intercept form. The slope here is 1, and the y-intercept is negative 5, so negative 5 there. And the slope is 1, so we rise 1, run 1, there's okay, and then there, and then there, and so on. Okay, we can then connect those points. So, try to get that as best as I can here. So, yeah, alright. This would be graph C. Alright, on to D. So what we can do with this is maybe switch it to slope y-intercept form. So I need to subtract 2 from both sides. I also need to distribute this negative 3/4 into the brackets. So we'll have, okay, so let's distribute that. That would be negative 3/4 x plus something. So 3/4 times 5 works out to 3.75, so plus 3.75, right? Negative times negative is positive. And then we need to subtract 2, right? So subtract 2. So the equation there will be negative 3/4 x plus 1, oh, it's crazy, x plus 1.75. So that's the equivalent equation in slope y-intercept form for D. So 1.75 is about there. One thing you can do is obviously put this into your graphing calculator, and it works out that there's a nice value. So if you scroll through the table of values, negative 3 and 4 is through the crosshairs, or alternatively what you could do is, so start from 1.75 and go down 3 and right 4, so 1, 2, 3, and then right 4, so we'd have to be there at negative 1.25, right? Because we're once, twice, 3 times down. That one just happened to be a nice intersection point. So I got 3 points to connect, so I can draw a line through those. Hopefully that's about parallel. More or less. You can probably draw this a little bit more accurately on your page. So that would be D. And finally the line x equals minus 6. X equals minus 6 for all values of y. So this would be like that. And that is E. So there's A through E first. That's done. On to F through J. So starting with 3y equals negative 6. I can isolate that for y, so I've got y equals negative 2. And that's a pretty straightforward one to draw. So y equals negative 2, just like that. So that would be F. Okay, next one, maybe isolate this for x and see what happens. So 8x equals minus 12. Divide both sides by 8, so we get negative 12 over 8. Negative 12 over 8 works out to negative 1.5. So x equals negative 1.5. So that would be here. And that is G. Okay, for this one using x and y intercepts, this might be a bit tight. So the x-intercept occurs where y equals 0. So starting with this equation, I put y equals 0 here and solve for x. So 2x subtract 3 times 0, which is 0. So it'll be 2x subtract nothing equals 12. So therefore x equals, I'll divide both sides of this equation by 2. You get x equals 6. So x equals 6 is the x-intercept. As for the y-intercept happens when x equals 0. So sort of a similar procedure. We put 0 in there and solve for y. So we have 0 subtract 3y equals 12. Divide both sides of that equation by negative 3 to solve for y. So we get y equals negative 4. Negative 4. So 0 comma negative 4 goes there. So I can connect those 2 points with a line, and that will be H. So hopefully, there we go. So that, try to do that in the same color. Okay, so that's H. Moving on, let's just get that out of the way a little bit. Okay, so 5x plus 2y minus 6. Rearrange it into slope y-intercept form first. So I want to get y on its own. So I need to subtract 5x and add 6 to both sides of this equation, which would give me 2y equals negative 5x plus 6. And I need to divide both sides by 2. Negative 5 over 2x. 6 divided by 2 is 3. So we have a y-intercept of 3 and a slope of negative 5 over 2. So rise 1, 2, 3, 4, 5, and run is 2. So that would be the next point. And then from there, 1, 2, 3, 4, 5, and then over 2. There we go. Okay, let's connect those 3 points. That's about parallel. Okay. Right. So this would be I. And we've got one last one on this page. Graph a line that passes through negative 3, 1 and is parallel to 4x minus 3y plus 8. So let's start by figuring out what the slope of this line is. So the line that we're wanting to graph needs to be parallel to this. I don't know what the slope of this line is just to look at it. So if I switch this into slope y-intercept form, then I can get the slope at a glance, and then I can use that point. So let's start by switching this into slope y-intercept form. So if I add 3y to both sides of this equation, I would get 3y equals 4x plus 8. Divide both sides by 3, giving me y equals 4/3 x plus 8/3. So I don't really care about that anymore. It's the y-intercept. As long as I got this right, so that's the slope we need, and is 4/3. We also have a point, so if we have the slope and a point, we should use slope point form. Y minus y1 equals mx minus x1. Plug in what we know, so our point will go y minus 1 equals 4/3 x plus 3. Okay, and then let's maybe get this into a form that's like slope y-intercept form. We can do that. So hopefully that'll be useful for me to graph, because at the moment I don't know really what that looks like. I mean, okay, yeah, I guess, well, I'll just write it in slope y-intercept form just for practice. I mean, as I got a point and the slope, I can piece it together what it'll look like on the graph, but maybe we'll get some kind of epiphany by writing it in slope y-intercept form. Probably not, but let's see. 4/3 x, okay, and then 4/3 times 3 will be 4, and then I need to add 1 to both sides, so y is equal to 4/3 x plus 5. So that'll work. I can use that to graph j, or, I mean, I probably could have just done this more simply by going negative 3, 1. So start there and build out. So you get the 4/3 slope. So 1, 2, 3, 4, and 1, 2, 3. Okay, look at that. It goes through where I would expect it based on this equation. So, and then we can go 1, 2, 3. Oh, okay, too far. 1, 2, 3, 4 down, and 1, 2, 3 right. So I can connect those points, and that's J. So hopefully that's about right. Get it through all 3 points, and that would be J. Alright, moving on. So, okay, number 2a. Determine the equation of each of the following lines in the form indicated. So we need general form for A. So this is y equals negative 4, right? but that's not in general form, because general form needs to be ax plus bx, or sorry, plus by plus c is equal to 0. Each of these letters, so capital A, capital B, capital C, all have to be integers, so A, B, and C need to be integers, and A needs to be also greater than 0. That's my condition to get general form, so this doesn't look like this. So I need to get everything to one side. I don't need to hit the requirement that A is greater than 0, because A is 0 to begin with. So we have y plus 4 equals 0. So that's as best we can do with that one. As for b, we have x equals 6. So x equals 6. Again, we need to bring everything to one side, making sure that the coefficient on x is positive. So I should bring the 6 to the left. So x minus 6 equals 0. That's the best we could do for general form. Okay, on to C. So we've got slope y-intercept form. That works for me. We have the y-intercept. That's 4. So, okay, so for C, we've got slope, or the y-intercept is 4. The slope, however, so we've got 1, 2, 3, 4, and 1, 2, 3, 4. So slope is rise over run, so negative 4 over 4, which reduces to just negative 1. So negative x plus 4 is equation C in slope y-intercept form. And last one for D. Okay, so for D, I'll just write that over here. We need to figure out the slope. So I have 2 points that we know cross through the crosshairs. So this is 5, 4. So there's 5, 4. And this one here is negative 3, 2. So negative 3, 2. That should be a 3. Negative 3, 2. Okay, so we can find the slope here. y2 minus y1, so 4 minus 2, divided by x2 minus x1, so 5, subtract negative 3. So 4 subtract 2 is 2, 5 subtract negative 3 is positive 8, so that's 1/4. And it's not a very good idea for us to sort of estimate this, because I know these 2 points go through exactly at those points, 5, 4 and negative 3, 2. This looks like it's probably, I don't know, 2.7, could be 2.8. We don't want to leave it up to chance though, so we can actually figure out what this is exactly. So it might turn out to be like 2.82 or something. So we want to know for sure. So how should we do that? Well, we have the slope, we have a point, we have 2 points in fact. Just pick a point, we'll pick that. So y minus y1, m x minus x1. And using this, we should be able to figure out what the y-intercept is exactly. So let's use this point, y minus 4 equals 1/4 x minus 5, and let's just simplify that a little bit. So y minus 4 equals 1/4 x minus 5 over 4, and I need to add 4 to both sides, so we get y equals 1/4 x, and kind of run out of space here. So negative 5 over 4 plus 4. I need to write 4 as a fraction with a denominator of 4, so I'd go like that. So negative 5 over 4 plus, this is still a 4, basically, just in different form. Okay, 16 minus 5 is 11, so 11 over 4. So I believe that works out to 2.75, which is, I guess what we would have expected. But we know for sure it's 11 over 4. So y equals 1/4 x plus 11 over 4. So that would probably be the better way to go rather than writing 2.75. Alright, so for 3 it's a little tight, so you may want to just work those out on a separate sheet of paper. 4 you might be able to get away with doing that on the same page, but I've made some space here, so we'll move on to question number 3. So question number 3, we need to determine the equation of each line in general form, so that's like this, where a, b, and c are integers, and a is greater than 0. We need that to happen. So line that passes through negative 2, 5 and is parallel to the y-axis, so it needs to be parallel there. Negative 2, 5 would be like kind of there, and if we're parallel, looks like that. So it would be x equals negative 2, right? But if we're going to write that in sort of more general form, x plus 2 equals 0. Alright, next one, negative 2, 5, so I guess it's the same kind of ish point. Negative 2, 5, but this time we are parallel to the x-axis, so we should be drawing a horizontal line. And the y value along here is 5, so we have y equals 5. And we need to get everything to the same side. Y subtract 5 equals 0. Okay, on to 3c. Something that passes through 2, 5 with a slope of 3/4. So if we have a point and the slope, we should use point slope form, y minus y1, m x minus x1. Put that in for m, so that's 3/4, x minus 2, and y minus 5, and simplify. So y minus 5, okay, let's distribute this. So that would be 3/4 x, 3/4 times negative 2 works out to be negative 3/2. I'd need to add 5 to that. Oh, I guess we can just kind of, yeah, let's do y minus 5. Okay, so in order for us to get this into general form, what we need to do is get rid of these denominators. So if I want to get rid of that 4 and this 2, probably the quickest way to go about doing that is multiplying both sides of this equation by 4, making sure that you are hitting each term. So the left side of that will give me 4y, whoop, let's try that again, 4y minus 20. This will be 3x, 3/4 x times 4 is 3x, and this will work out to be 12 over 2, which is 6. Okay, and now we just need to bring everything to the one side. It should be to the right side because x is positive. So let's go 3x. I would subtract 4y to bring it over to the right, and negative 6, I would need to add 20 to both sides to bring this to the left as well. So now I'd have everything on the left here be 0. So if I add 20 to negative 6, it's basically 20 subtract 6, which is 14. And that's our equation for 3c. Okay, 3d, kind of a similar concept. This time we're given the y-intercept. So the y-intercept is 5. That means we have a point at 0, 5. I mean, we could use point slope form again, but given the fact that we have the y-intercept, it's a little bit easier to do this form, y equals mx plus b, because I have the slope, I have the y-intercept, just put it in, so negative 2/3 x plus 5, and yeah, that looks great, but we need it in general form, in order to get rid of the denominator here, just multiply both sides of this equation by 3. Don't forget to distribute. So the left side of that equation will just be 3y. Right side will be negative 2x plus 15. The coefficient on x is negative, so if I want to make it positive, I'm going to bring everything to the left. So I would have 2x plus 3y, and I need to bring this to the left as well, so I need to subtract 15 from both sides, giving us that. So there's 3d. Moving on, 3e. So slope of 1/2 and an x-intercept of 3, so that means 3, 0. We can't do the same procedure we did on the very last question for d because we don't have that special point, right, the y-intercept. This is this time the x-intercept. So this time we're going to use point slope form. I have the slope, so that would be 1/2. Okay, and then x minus 3, right, x, and y minus 0, so that'd just be y. Okay, and again I want to get it into general form, so I need to get rid of this 2. I can multiply both sides of this equation by 2. So that kind of saves me a little bit of work, right? So rather than distributing this 1/2 into the x and the negative 3, I just kind of keep it out, and then I only have to distribute that to that thing, right? Because it's multiplication. So then we get 2y equals x minus 3, hopefully. So 2y equals x minus 3. Bring everything to the right because x is already positive coefficient. So we'd have x minus 2y minus 3. So that's 3e. Moving on to f, parallel to this line with a y-intercept of negative 3, so that means 0, negative 3. We need to figure out first what's parallel to this. I don't know what the slope of this line is to look at it, so I'm going to maybe switch it to slope y-intercept form. So I'll get y on its own. I'll bring negative 3y, I'll bring that to the right. So 4x minus 7 equals positive 3y, right? I add 3y to both sides, that happens. And then divide both sides by 3. So I would get 4/3 x, and it really doesn't matter what the rest of it is because I already have the slope, but I guess just for posterity, subtract 7/3. So 4/3 minus 7/3, that's my required slope for the line that I'm about to draw. Okay, so I guess we can use slope y-intercept form. That's pretty convenient because we have the y-intercept, so that's negative 3. So 4/3 x minus 3. I want to get rid of the denominator, right, because general form I cannot have fractions hanging around. So multiply everything by 3. That gets both things in there. The left side becomes 3y. The right side becomes 4x minus 9. I want to keep this positive, so I'm going to keep everything to the right side, so I'll bring this one over to join them. So 0 equals 4x minus 3y minus 9. Okay, and that's 3f. 3g. So something passing through to negative 3 and parallel to this. Okay, so that's great. We know the slope is negative 2 because that's slope y-intercept form. Passing through this point, so I have slope, I have a point. We should use slope point form, mx minus x1. So the slope is negative 2. X minus 2. and y subtract negative 3 will be y plus 3. I can now distribute this negative 2 into each of these terms, giving me y plus 3 equals negative 2x plus 4. Right, negative 2 times negative 2 is positive 4. Coefficient on x is negative, so I need to make that positive, so I'll bring everything to the left. So if I add 2x to both sides, I get 2x plus y, and then I need to subtract 4 from both sides, so 3 subtract 4, negative 1, that's 0. So that's 3g. Okay, 3h, passing through this point and perpendicular to that line. So we need to figure out what's perpendicular to that line. Probably just convert this to slope y-intercept form. So let's get y on its own. So I'll do that by subtracting x from both sides and adding 7 to both sides. So in one step, that would be looking like this. 3y equals negative x plus 7. Then I just got to get rid of this 3, so divide both sides by 3. Negative 1/3 x plus 7/3. I didn't really need that piece because I need something that's perpendicular to this. So my slope perpendicular to this slope would be, well, flip these numbers and make it positive, right? So yeah, it's currently negative, let's make it positive, and the numerator switches with the denominator, so we get just positive 3. So that's the slope I need. I got a point, slope point, y minus y1 equals mx minus x1. Slope is 3, x minus negative 4, so x plus 4, y minus 0, so just y. Distribute this 3, y equals 3x plus 12. Just need to bring this y over. So 0 equals 3x minus y plus 12, right? I subtract y from both sides there. So that's 3h. On to 3i. So something that passes through these 2 points. I have 2 points, I need to find the slope. So slope is, call that x1, sorry, let's do x2, y2, that's x1, y1. So we'll do minus 3 subtract 1 divided by 1 subtract negative 5, right, because rise over run, or y2 minus y1 over x2 minus x1. Negative 3 subtract 1 is negative 4. 1 subtract negative 5 is the same as 1 plus 5, which is 6. That reduces to negative 2/3. So we have our slope, and we have 2 points to choose from. So slope point form, point slope form. Negative 2/3 goes in for m, so negative 2/3 x, and pick your point. I'm going to maybe go with this one. So x minus 1, y subtract negative 3, so y plus 3. And simplify, so y plus 3 equals negative 2/3 x plus 2/3. So going about it a little bit differently than the last question that I did here. I think I was able to get rid of this in one step earlier. You could do that just as quickly here, so I could have multiplied everything by 3 at this stage and saved myself a little bit of work, and I wouldn't have had to distribute this in, but now you can see how it's done with, like, after distributing that term. So in order for me to get rid of this denominator, I need to multiply both sides of this equation by 3. make sure you get both terms on both sides. So this will be 3y plus 9 equals negative 2x plus 2. I need to bring everything to the left because the coefficient on x is negative. I need to make it positive, so let's add 2x to both sides. Add 2x, so that would give us 2x plus 3y plus 9 equals 2, and then subtract 2, so that would be 2x plus 3y plus 7 equals 0. So that's 3i. This might bring that a little smaller. Okay. 3j, x-intercept of 2, y-intercept of 4, so x-intercept of 2, that's that coordinate, y-intercept of 4 is 0, 4. I need the slope, so y2 minus y1, x2 minus x1, so this would be 4 subtract 0, 4 subtract 0, divided by 0 subtract 2, 0 subtract 2, so that'll be 4 divided by negative 2, which reduces to just negative 2, so that's the slope I need, and let's use point slope form, mx minus x1, so negative 2 goes in for m, and I can pick my point. I can either use this one or this one. I think in this case I'll go with this one, just arbitrary, but I mean you can pick this one. You'll end up at the same place though. You can try that. So x subtract 0, y subtract 4, so right side will be negative 2x, y minus 4. I need to bring this one to the left, so 2x plus y minus 4 equals 0. So that's 3j. Last question, number 4, algebraically determine the value of k if this line passes through negative 2, 1. So we have an x and a y value that this line passes through. So that's convenient. I can sub the x and the y value in, and that forces this line, for lack of a better word, to pass through this point. So by putting these values in for x and y, that ensures that k adapts to whatever value it needs to be to make that happen. So 3 times negative 2 plus 2k times 1 minus 5 equals 0. So now hopefully you can see we just have an equation for k, and I solve for k. So negative 6 plus 2k minus 5 equals 0. I can simplify the left side a bit here. 2k subtract 11 equals 0. Add 11 to both sides, so 2k equals 11. And divide both sides by 2. K is equal to 11 over 2. So that's it. See you next time.